Good morning. This recording is for Algebra 1, Chapter 8, Lesson 3, multiplying binomials. The only thing is we're actually going to be multiplying trinomials as well. So you're going to see a binomial times binomial and a binomial times a trinomial coming up today. All right, and so for two of the things that we're doing today, the binomial times binomial and then the binomial times trinomial, there's two different ways to do it. You can choose which way you want to do it. It is up to you. All right? So there's two ways of multiplying two binomials. And the first way is very similar to the distributive property where you break it up. For some of my classes, I call this the king-pig distributive property, where basically you're taking 99 and you're rewriting it. So you're taking like the king-pig in Angry Birds, and you're breaking it up into two smaller pigs, whereas the number outside of the parentheses, in this case the 8, is the Angry Bird, and it's like the yellow Angry Bird, or no, excuse me, it's a little blue Angry Bird. A little blue Angry Bird where you click on it and then it like separates or multiplies out into, multiple little birds that then attack the pigs. So that's kind of what's going on. So for some of you who've heard that analogy, that's what I'm referring to here. So what we're going to do is we're going to break one binomial into two and distribute, just like we did with the little blue Angry Birds when we were doing distributive property in pre-algebra, because again, the distributive property never goes away. All right, so here we go. Here's our problem. We have 5m to this plus 2 times 8m minus 1. So I'm going to break up the first one, the 5m and the 2, into 2, and I'm then going to multiply each of those that I broke up times 8m minus 1. So we're going to have 5m times 8m minus 1 plus, because the thing that I broke up has the plus. All right? Since the thing I broke up here has a negative, a minus, that's what it's actually going to end up being. Since this one has a plus right here, it needs to have a plus right there. All right, and then we're going to add 2 times 8m minus 1. And there we go. Forgot the last parentheses. So let's go ahead and distribute. So 5m times 8m minus 5m minus times 1 is going to be 40m to the second, because I have two m's that are being multiplied together. So 40m to the second minus 5m, because 5m times 1 is 5m. And we're going to add 2 times 8m, which is 16m, minus 2, because 2 times 1 is 1, and that's a subtraction. And then we're going to combine like terms. So since it's negative 5m plus 16m, those are like terms because they have the same variable to the same power. We're going to do plus 11, because negative 5m plus 16 is positive 11, minus 2, and that is our final answer. All right, there we go. All righty, so next problem. That was the combined like terms, by the way, guys. All right, so this is the second way you can do it. The other way is to break things up and then distribute. This way is you're not breaking anything up, but you're doing this massive distribution. And this massive distribution is called FOIL, and this will never go away. If you say FOIL to any other person who's been in this class or higher, any math teacher, and you say FOIL, they're going to know exactly what you're talking about. Because there's really no other way of describing it other than FOIL, though personally to me FOIL is really confusing, but I just know that I'm doing massive distribution. I'm going to distribute the first two together, the first and the outer, the inners, which is the ones in the middle, and then the last, which is the last ones there. Or I describe it as the first term of the first binomial multiplied by each term in the second binomial, and then the second term of the first binomial multiplied by each term in the second binomial. So it's going to look a lot like this. FOIL, which is f, which is the first, so the first two terms in the binomials get multiplied together. Then we're going to do the outer. So the outer of the binomial terms in the binomial. So that would be the 3x times the negative 5, and it's negative 5 because I add the opposite, because it was originally subtract 5, right? Subtract 5, but then I added the opposite, right? And that's going to give me 3x times negative 5. And then I'm going to do the inner ones, the ones in the middle. So it's basically the last term of the first binomial and the first term of the second binomial. And that's going to give me my inners, my inner ones. So it's going to be negative 4 times 2x plus my last ones, the last term of the first binomial and the last term of the second binomial. So that's FOIL, F-O-I-L. So remember to FOIL. All right, so, and again, this is how most people will describe. You can still do the first method, the first way, which was on the previous slide, but a lot of people use the FOIL method. All right, so let's go ahead and simplify. So we're going to have 3x times 2x, which is 6x squared, plus 3x times negative 5, which is negative 15x, plus negative 4 times 2x, which is negative 8x, plus negative 4 times negative 5, which is positive 20, and then we need to combine like terms, and that's going to give us 6x squared plus negative 23x plus 20. All right, moving on. We can use the same methods to help us figure out the area of the shaded region. So we have this big shaded rectangle, and inside we have a rectangle that's not shaded. We want to find the area of the shaded region only. Okay? So the first thing we're going to do is we're going to figure out the area of the bigger rectangle and then subtract the area of the smaller rectangle, and that's going to give us the shaded region. All right? There we go. All right, so the area of the big is 5x plus 8 times 6x plus 2. And then we're going to subtract the area of the small one, which is 5x times x plus 6. And again, we're going to, this is the FOIL method. I didn't break it up, and I will actually do FOIL for the rest. If you're not comfortable with FOIL and you like the first method, fine, that's great. But just be aware, I'm going to probably FOIL for the rest of the year. So make sure you're familiar with FOIL so you don't get confused with what I'm doing. All right, so 5x times 6x is right there, and then 5x times 2, and then 8 times 6x plus 8 times 2. So that was FOIL again, which gives us this. Now I'm going to distribute, which is going to give me that, and the only thing is this actually is supposed to be a plus, because I originally wrote it as subtraction, which was wrong. So because this is like, yeah, anyway. I messed up earlier, caught it, and fixed it, but some of my fixes haven't like gone all the way through. All right, so there we go, which simplifies into that, and then we're subtracting. So let's go ahead and first I added the opposite, and then the opposite goes to everything in the parentheses, right? Because we're subtracting this whole amount. So those all become negative, and then we're going to combine like terms and put into standard form. And remember, standard form is the highest degree of exponent to the lowest degree of exponent. All right, so combine like terms, that's going to be 30x to the second plus negative 5x to the second plus 10x plus 45x plus negative 30x, or 48x plus negative 30x plus 16. Combine like terms, and it's going to be 25x squared plus 28x plus 16, which is the area of the shaded region. Now, if you only knew what x was, yeah, well, if you only knew what x was, it'd probably be a little easier. But you know what? If you didn't know what x is, that's how you do it. All right, moving on. All right, so this is the multiplying a binomial times a trinomial. And we know it's a binomial times a trinomial because the binomial has two terms, which is the 6x and the negative 8, or 6x minus 8. And the trinomial has three terms, which is the 2n to the second plus n plus 7. And I'm going to actually do this problem twice. Once with the first method, which is what we call the vertical method, which is very similar to old-fashioned multiplication. You'll see it and you'll be like, man, that's like kind of cool that it works that way. And then the other method is going to be similar to FOIL. But first method first. Let's go ahead and line these up. And again, just like multiplication, we tend to put the bigger number on top, or at least the number with the more terms. All right, the thing that has the more terms. So we're going to put, oh, and I added the opposite there. We're going to put 2n to the second plus n plus 7 over 6n plus negative 8. And just like regular old-fashioned multiplication, like you're doing with just digits, you do need a placeholder, and I will get to that in just a second. All right, so let's go ahead and start multiplying. We have 7 times negative 8, which is negative 56. Then we're going to have n times negative 8, which is negative 8n, and then we're going to have 2n to the second times negative 8, which is negative 16n to the second. Notice how they're all in order. They're all in standard order. The thing is that the next thing that we're going to multiply, which is the 6n to the 7th, the answer needs to be under the answer to this problem, 6n times 7, needs to be under the same term that are like each other. So it needs to be under something that also has an n and only an n and not an exponential n. So this is where the placeholder comes in, because this is not a constant. 6n times 7 is not a number without an n. So it has an n, so it needs to go under something else that also has an n. So 6n to the times 7 is going to be 42n. So notice how I put it underneath the negative 8n because they're like terms. I'm going to have to put them together at some point, so I might as well put them underneath each other. And then I'm going to have 6n times n, which is 6n to the second, and then I have 2n to the second times 6n, which is going to give me 12n to the third. Now, since everything's in standard form, I can go ahead and add, just like old-fashioned multiplication. So negative 56 plus 0 is negative 56. Negative 8n plus 42n is 34n. And negative 16n squared plus 6n squared is negative 10n. And then we just have the 12n to the third power. Hold on one second. Okay, so that was the first method called the vertical method. And again, it just works like old-fashioned multiplication. The second method works a lot like FOIL. Now remember that answer, 12n to the third plus negative, all that stuff in the box, because we're going to do the exact same problem, but with a different method. And that would be method 2, and that's the FOIL-esque, aka horizontal method. And it's the same problem, but with FOIL on a trinomial. So we're going to distribute property everything. 6n times 2n squared, 6n times n, and 6n times 7. And then we're going to do negative 8, because I'm going to add the opposite in just a second. Negative 8 times 2n squared, negative 8 times n, and negative 8 times 7. There we go. So that's the first part, which is actually what I had shown in the orange arrows. So don't get confused. That's not, the purple arrows don't match the purple text that I just showed you. Okay? They actually match the orange. So then the new purple is actually what matches the purple arrows. And there's my add the opposite. I turn that into an add negative 8 as opposed to just minus 8. Now, let's go ahead and simplify this sum because it's pretty honkin'. It is pretty honkin'. Let me actually make it a little bigger for you in case you're having trouble seeing. Let's see here. Oh, I can't actually move all that. Never mind. I won't waste your time. All right, so let's go ahead and simplify. 6n times 2n squared is 12n cubed, or 12n to the third power. And then we have 6 times n squared, 42 times n, negative 16n squared, plus negative 8n plus negative 56. Combine some like terms, people. There's some like terms, there's some like terms. Let's go ahead and add them. We're going to have 12n to the third plus negative 10n squared plus 34n plus negative 56. And if you check it out from the previous answer, which I copied and pasted, yeah, that looks pretty good, right? And the only difference is the add the opposite right there. Same answer, two different methods. It's your choice which way you want to go, but then again, the whole FOIL thing is like really ingrained in algebra, so you should know it even if you don't use it. Okay? And the last thing I want to tell you guys is that if you would like some more example problems, because I actually didn't do all of the ones that are A in the book or B in my notes, you can go to Google Drive, shared with me, and look for Algebra 1 notes. In there are a ton of PDFs by chapter and then by lesson of all of the notes that I have for this lesson. And even though I don't work out all of the problems, there are a ton of example problems in there. So if you need more problems to help figure this out, go ahead and work on those. And if you need help figuring those out, you can come talk to me. All right, I'm done. Bye, guys.